Okay, in this video we're going to show you how to go from atoms to moles. Now this is a pretty simple conversion, but it's also very, very important that you get it right because it's going to lay the foundation for other problems that you solve. Alright, so step one, you have to understand that 1 mole contains 6.02 times 10 to the 23rd atoms. Right, now it's a very big number. Like if you had a dozen eggs would be, like 1 dozen eggs would be 12 individual eggs. So 1 mole of a particular substance, or 1 mole of atoms, is 6.02 times 10 to the 23rd atoms. All right, so you're going to need that first. And you're going to make a conversion factor, okay, based on the number of atoms that are given to you in the problem. And then once you have that conversion factor, then you can calculate how many moles there are. All right, but make sure that you label things as you go, because if you don't put the numbers in the correct position, like for example the numerator or the denominator, then you're going to mess up the problem. So label everything, okay? Watch the video and you'll see what I mean. All right, time to show you how to convert atoms to moles. So let's read the problem together first. It says, if a sample of neon has 3.6 times 10 to the 25 atoms, okay, underline that, how many moles is that? Okay, so we are given atoms and we're looking for moles. One really important fact to keep in mind is that an atom is a type of particle, okay? Just remember this for a second, okay? It's maybe a little silly information, but it's important. There's lots of particles that are in chemistry. There's molecules, there's atoms, okay? Either way, whenever you're dealing with moles and particles, 1 mole is always equal to 6.02 times 10 to the 23rd, okay? So that's whether you're talking about moles of atoms or moles of molecules, okay? Could mean either or. Now in this particular situation we're dealing with atoms, so we're going to try to stay focused on that. Alright, so I'm going to take my blue pen here and I'm going to solve this in 2 ways. The first way is the dimensional analysis style, which is my personal favorite. 3.6 times 10 to the 25 atoms of neon. That's what we're given here. So for dimensional analysis, you always start with the given information, and then you need to use some kind of conversion factor. So we have to use something that's going to allow us to go from atoms to moles. And you kind of got the hint from what I wrote up here at the top. So I'm going to draw a line, and then I'm going to write 6.02 times 10 to the 23rd atoms of neon. And in the top I'm going to write 1 mole of neon, which is abbreviated MOL. And that's it. That is all you need to do for the setup of this problem. Atoms of neon cancels with atoms of neon, so we can be assured that we're going to be left with moles of neon at the end of the problem. So, time to do some math. On my calculator, I'm going to type 3.6, and then to enter this part of the number, I'm going to hit second function, and then hit the EE key, and then type in 25. Ah, almost got me. You see, this E actually takes the place of the times 10. So you don't need to write that because the calculator understands that when you write an E, that it means times 10. And this 25 is what the 10 has been raised to. So I'm going to take this number times 1, which isn't going to do very much. And then I'm going to divide by 6.02. Again, second function, EE. And I just need to type in 23. Okay, so my final answer becomes 59.8, and that's moles of neon, okay, which I'm abbreviating as MOL. Okay, so that is the dimensional analysis style for doing these kinds of problems. Now, if you like this method, then that's all you need to do. You can stop the video here. If you want to see another way to do the video, or to do the problem, then what I'm going to do is solve another piece of it down below here. Okay, so In order to do this, I need to introduce you to a concept using a system of triangles. And so here is the way that this system works. You draw a triangle and you divide it into 3 parts. Okay? So in this case, I'm going to make a triangle that includes atoms. So I'm going to write atoms up here. I'm going to put moles over here. And I'm going to put Avogadro's number in here, which is 6.02 times 10 to the 23rd. Okay? So this is the kind of triangle that we're going to use for solving this problem another way. Actually, we'll use the black for this time. Okay, so with my particular problem, I'm going to put in those values. So I was given 3.6 times 10 to the 25 atoms. So I'm going to write that up here. Down here I'm going to write Avogadro's number. And then over here I'm looking for the moles. Okay, I'm looking for my moles of neon. So now I'm going to use this triangle. I'm going to transform this into a math problem now. So it's X moles of neon is equal to 3.6 times 10 to the 25 divided by 6.02 times 10 to the 23rd. And that's all I need to do. So I'll enter these numbers on my calculator just to show you that it works either way. 6.02 EE 23, and there you have it. So whether you do it with the dimensional analysis style or whether you solve the problem using this triangle method, you're going to get the same answer. Now your teacher may or may not prefer this method, and that I'm going to have to leave up to you to figure that one out. Okay, but here is the problem solved using 2 methods. You can either use the dimensional analysis style or you can use the triangle method that I showed you below. Okay, you just got done watching an atoms to moles problem. So check it out. You've got Avogadro's number involved in these kinds of problems. That's 6.02 times 10 to the 23rd of whatever it is you're talking about. So if we're talking about atoms, 1 mole is Avogadro's number of atoms. So once you recognize this, you can make a conversion factor where you have 1 mole of a substance is for every 6.02 times 10 to the 23rd atoms. Okay? Once you put that conversion factor in the right place and you have the right thing in the numerator and the denominator, then you just solve and you'll get your answer. So pretty important, pretty basic, but definitely practice this and make sure that you have it down because problems are going to build on this basic foundation down the road. All right, that's all I have for now. I'll see you next time.